Dear colleagues, again, many thanks for joining us for this first international workshop on scientific analysis of pottery finds from Africa. In this presentation, I would like to highlight the first results from archimetric analyses conducted on pottery sherds from the Congo Basin, with a specific focus on clay sourcing and preparation strategies. The main goal of my current project is the reconstruction of transgenerational training networks in the Congo Basin. This region is a prime study area, as specific recipes for pottery production are believed to have been handed down for multiple millennia into modern times. The only widespread archaeological fieldwork in the area was conducted between 1977 and 1987. The fieldwork of the River Reconnaissance Project, you can see some basic details here, resulted in a basic chronotypological framework consisting of 56 pottery styles covering the past 2,400 years. The primary approach was to survey with a small barge called Engenje, which is Lingala for water turtle, along the main tributaries of the Congo River and conduct limited excavation at selected sites. While the focus on river surveys has been debated regarding representativeness, barely any research has addressed the issue with new data. Including here, this is not based on new fieldwork, but on lab research alone. But now, putting the rivers in the center, I aim to evaluate clay sourcing strategies that pottery communities have followed over the past 2 millennia. For this goal, I selected inventories from 5 sites in 2 regions as separate case studies. The sites of Pikunda and Munda are located in the western Congo Basin, while Bafanya and Monkoto are located along the Luilaka River in the inner Congo Basin. A real novelty in this paper are the 2 localities labeled SNG. These are petroanthropological trenches dug by my co-author Vannes Hubot, about 3.2 to 3.7 kilometers from the Luilaka River on the terra film. The circles on the right show the topography around each site. Based on the available geological data from the region, or better, the lack of detailed geological data, not much can be said about the geology around the sites. Pikunda and Munda are surrounded by very young Holocene sediments, while the sites along the Luilaka are in a Cenozoic sedimentary body that constitutes the main infill of the Congo Basin, with the rivers having carved itself into and partially revealed Cretaceous units. In the following, I want to give you a very brief overview of the chronocultural framework in the 2 case studies. In the Western Congo Basin, the earliest well-documented pottery is named after the 2 sites selected for this study, Pikunda Munda, and dates between the 1st century BCE to around the 4th century CE. You can see some of the characteristic bowls as numbers 1 and 2 on the left. All traces of this style vanished in the subsequent centuries until a new tradition emerged in the 14th century CE. Now, globular pots are predominant, and this new tradition shares no stylistic similarities to the preceding pottery. But it directly connects to modern potter's production documented at Pikunda. Whereas Pikunda Munda bowls were potted by drawing of a ring technique, the newer tradition, again as the modern potters, worked by coiling. The sampled sites on the Luilaka are located at the limit of the distribution of the oldest pottery in the Congo Basin. This Mbonga pottery dates between the 4th and 2nd century CE. The sites are more representative of the subsequent phase described by a chain of individual pottery styles. The oldest among those is the Monkoto style, examples of which you can see as vessels 1 to 3 on the right. A novel radiocarbon date places the Bekongo style into the 9th century CE. This is important, especially if you followed earlier publications of mine regarding a setback in human activity in Central Africa between the 6th and 10th century CE. Previous relative approaches placed the style far younger. However, now it looks like it predates the longer style with its characteristic carinated bowls, like you see in number 6 in the figure on the right. Especially noteworthy, though, are the new sherds from the petroanthropological trenches in the Sasalonga National Park unearthed by Wannes Ubo. These are shown in the color plates on the lower right. Except for one sherd, they shared little to no stylistic similarities with the inventories from the two nearest sites on the river. This caused some irritation, as the predominant hypothesis was that the extensive surveys along the rivers returned a representative insight into the ceramics of the region, including the hinterland. After this long introduction, I want to discuss the archaeometric analyses I conducted. I selected 40 sherds for thin sectioning, and the chemical composition of all of those plus 3 additional sherds was investigated using a handheld XRF device. The main goal of this study is to deduce, as I call it, the local, intermediate, or translocal nature of the vessels. This is important as the lingering notion remains that these ceramics are the product of some unspecific local production. At the same time, modern pottery is made in distinct potters' villages and traded throughout the region. The most striking indicator for the clay source I could find are fragments of the siliceous skeletons of freshwater sponges. These so-called sponge spicules appear as elongated isotropic rods in plain polarized light. In the upper left image, you can see an example from a clay sample from a site in the inner Congo Basin. However, they are not only detectable in thin sections, but also on the surface of the sherds. On the lower left, you can see a stacked image from the surface from another sherd done with a reflective light microscope. These distinct features are a clear indicator of the clays having been deposited in a riverine or lacustrine environment, as the freshwater sponges with such spicules grow on tree trunks in semi-inundated mangroves, similar to the situation photographed on the lower right. These sponge spicules are in a lot of samples, but not in all that I expected them in. For example, this sherd from the Luilaka River, there are only very few sponge spicules in the main body, but the grog, you can see one piece in the lower left of the photomicrograph, this clay was tempered with, was derived from pottery quite rich in sponge spicules. Sponge spicules, while they are well known from Amazonian ceramics, have never been reported from Central African pottery before. Throughout Africa, I found limited reports of sponge spiculated pottery from Mali, Sudan, and the Great Lakes region of East Africa. Thus, there's still room for untangling the bigger story of this particular marker for the usage of riverine or lacustrine clays in the Congo Basin and beyond. But coming back to the image on this slide, this fabric also regularly shows considerable quantities of charred organic material, like the charred seed on the right of the image. As indicated, another intriguing petrographic feature in the sherds from the Luilaka are increased amounts of charred plant matter. We did a micro-CT scan for one sherd that had a charred plant remain already visible on its surface, which proved very informative. In addition to multiple charred seeds being visible, it highlighted another intriguing feature: long planar voids. In the thin section, these could easily be identified as charred parenchyma of Pauacea, or in layman terms, grasses. At this point, I found no reference for this type of tempering agent. Among the curiosities I want to highlight is this sherd from Picunda, which has a piece of slag embedded in it. The style is equivalent to the modern potter's products at the site. I showed you a photo earlier. You can see the lath of firelit crystals in an opaque matrix. While I found systematic slab tempering in samples from the southern edge of the Congo Basin, this is the only instance I know from the Congo Basin itself. I'm still debating whether I have a case of intentionally tempering with slag, or if the particle ended up in this sherd by pure coincidence. But beyond these anecdotal examples, the main objective is to organize all the features observable during petrographic analyses: sponge spicules, charred plant matter, rock fragments, grog, and so on. For that reason, I coupled a qualitative approach with multivariate statistics by building on a paper by Miguel Angel Chao et al. From the early 2000s. I recorded expressions of main features in a table and run a multiple correspondence analysis, or MCA. The results from that show the multivariate structure encoded in my dataset reduced to a two-dimensional space. While this method is standard in many fields, it is rarely used within ceramic petrography. The biplot in the center shows the samples from Picunda and Munda colored by their phase or style. The loading plot on the right shows the individual expressions of features in correspondence to the biplot. The results of the MCA can be further refined by subjecting its results to a hierarchical clustering on the main principal components. I used the first 5 eigenvectors for this. The suggested clusters can be seen as gray boxes in the biplot. The output on the left shows the description of each cluster based on its statistically significant features. The numbers given indicate how many samples showing a feature end up in a given cluster, how many samples in a cluster show a given feature, and how many samples in the entire dataset show this feature. Just as an example on how to read this, in cluster 2, 80% of samples with frequent sponge spicules ended up in that cluster. Among the samples in cluster 2, 94% showed frequent sponge spicules, while 71% in the entire dataset show this feature. I think it's quite clear how, if you start understanding this kind of output, this helps to refine further and subsequently understand any patterns present in the recorded data. In summary, for case study 1, this analysis shows that Picunda Munda shirts colored in pink are clearly separated petrographically from all younger materials seen in bluish colors, except for the samples of the Ebambe style in red. In conclusion, at Picunda, the potters of the Mandombe style and modern potters use different clays from those used in earlier phases. In contrast, at Munda, it seems the same riverine clays were used for the past 2,000 years. Along the Luilaka, the petrographic analysis revealed an even more distinct grouping, with 5 clearly separated clusters, each representing a petrofabric. Interestingly, the novel pottery that my colleague Vannes excavated on the terra firma between Bafania and Mongoto constitutes its own group that is at least somewhat close to the Congo samples from Bafania. Also noteworthy is cluster 4, which comprises one shirt from the terra firma that resembles the Bukuma style and a shirt from Bafania associated with the Mongoto style. But both these groups could be contemporaneous. However, I still have some work to do to refine this aspect of the analysis. As mentioned earlier, the second line of reasoning involved geochemical probing of the shirts using a handheld XRF device. I choose to take 3 measurements per sample, each lasting 60 seconds. The resulting reports, an example of which you can see in the middle, were tabulated and a reasonable subset of diagnostic elements was selected. As you can see on the right, inspecting correlations between these elements was already informative, as some groupings became apparent. PCA of these chemical data reveals some intriguing patterns in both case studies. The samples are plotted against the full dataset, the gray dots, which includes 180 samples from 60 sites from the entire Congo Basin, 2 sites in southwestern Cameroon, and 1 south of the Congo Basin. The previously observed differentiation between Picunda Munda samples and the younger groups is still present in the chemical data for the samples from the western Congo Basin, displayed in the middle. The sponge spicule-rich river clays have an especially low concentration in iron but high silica content. While silica is mainly regarded as a reference for quartz, petrography showed all shirts containing similar amounts of quartz. Thus, the high silica content must be caused by the amount of sponge spicules. In short, samples on the right side of the 2 biplots are characterized by sponge spicules, while those on the left are of a different, potentially terrestrial source. One interesting note, at Picunda, a single sherd of the Lusaka style was found. This style is prevalent further east in the Congo Basin. Petrographically, it is similar to the Picundamunda pottery, but chemically very different, as you can see in the position of the green downward triangle on the bottom of the central plot. On the right biplot, which shows the data from the Luilaka, the petrographically grouped sherds from the Terra film show quite a spread though, which I need to review further. In general, the first eigenvector of the PCA reflects basic clay sources. River clays on the right, with other potentially terrestrial sources on the left. I'm still trying to figure out if the data from the Henfeld XRF are any good for provenancing though. In an attempt to provide you with a preliminary synthesis, during the early Iron Age in the Western Congo Basin, potters producing Picundamunda style pottery unanimously used river clays rich in sponge spicules, indicated here with a red frame. While the stylistic tradition of the Picundamunda style disappeared, potters at Munda still used the same clay source up into modern times. Most probably, this goes back to them being influenced by communities in the adjacent inner Congo Basin, as younger pots at Munda show close stylistic relations to the pottery further east. The most intriguing insight comes from Picunda though, here shown as green in green borders. The younger pottery at this site is made from entirely different clay sources, not showing any traces of sponge spicules, but a considerable heterogeneous mineral component. Coupled with the change in stylistic characteristics and shaping techniques, it seems safe to say that at Picunda, the genealogical network of potters was replaced by a new community during the onset of the late Iron Age in the 11th to 12th century CE. On the Luilaka River, the observed pattern is even more intriguing. During the early and late Iron Age, samples corroborate the use of river clays, again marked by red frame and defined by them being rich in sponge spicules. But during the Middle Iron Age, a phase previously believed to experience a setback in human activity, different clays were used, and grog tempering became prevalent. These samples are here marked in yellow. These other clays were less rich in sponge spicules though. Thus, in summary, it seems as if potters' communities along the Luilaka experienced some impactful change, but that recipes for clay sourcing and preparation reverted back to the previous way of doing so after a few centuries the most. While I'm still working on fulfilling the initial goals of my research, deducing the local, intermediate, or translocal nature of vessels, I made some steps forward in terms of describing the clay sourcing and preparation stages of potters' communities, chaînes opératoires, in the equatorial rainforests of Central Africa. In terms of the importance of rivers, for lots of potters in the region, rivers have been the prime mode of transport and the source of raw materials for pottery production. But as we saw from the novel sherds my colleague excavated, much is still to be researched when we deviate from the well-trodden path. And with that, I thank you very much.